So obviously, this is how you identify the sides of a right-angled triangle. Okay, so if you see in the objective that it depends on the angle, it depends on which angle they are talking about. For instance, if I am talking about this angle, then this is no longer the opposite. This becomes the opposite. And then if this is the opposite, then this becomes the adjacent. But the hypotenuse is always permanent. That one is always the side which is directly opposite to the right angle. So I want you to have that understanding. I hope that is very, very clear. Okay, so let's go to the other stage. Now that we know how to identify the sides of a right-angled triangle, let's move further to see what we can do for. Good. So basically, we have three basic trigonometrical ratios. The first one is the sine. Make no mistake about it, like what students normally say, the moment when they see this, they say sin. It's not sin, it's sine. And the abbreviated form of it is SIN. So in most cases when you are solving problem, you cannot write the whole sign. It's the abbreviated form of it that you always write, which is SIN. Okay? So that is one trigonometrical ratio. We call it the sine. The other trigonometrical ratio is the cosine. The cosine, C-O-S-I-N-E, but it is abbreviated as cos. So when you are solving the problem, actually, you will be dealing more with the abbreviated form of it. You will be dealing more with the abbreviated form of it. And the third one is the tangent. The tangent is also being abbreviated as TAN. Okay? So basically, these are the three basic trigonometrical ratios we are going to talk about. All right? We are going to define all of them. All of them. Of course, they use the word trigonometrical ratios because they are all ratios. This has a ratio, this one has a ratio, and this one also has a ratio. And that is what I am going to talk about now. All right? So like you see, this is a right-angled triangle. And in this right-angled triangle, we want to find the ratio of the sine. This is the ratio of the sine. The sine is always opposite all over hypotenuse. In other words, for this angle, it is the opposite all over the hypotenuse. That is the ratio of the sine. Don't forget, opposite all over hypotenuse. That gives you the ratio of the sine. Okay, so you have the cosine. The cosine is adjacent all over hypotenuse. So you see, it's easy to remember. They all have the same denominators, hypotenuse, hypotenuse. But when it comes to the numerator, the sine always goes with the opposite, and the cos always goes with the adjacent. So it's easy for you to remember that sine theta is always opposite all over hypotenuse, and the cos of theta is always adjacent all over hypotenuse. All right? I hope that is clear. Then finally, we have the tan. The tan is always opposite all over adjacent. Okay? So it's only the sine and the cosine that has the hypotenuse. For the tan, it is always opposite all over adjacent. All right? So, but I'm sure this one is very, very clear. If it is not very, very clear, I think that is, I'm going to develop a kind of acronym they always use, which help you to remember these things. If you cannot basically remember all the trigonometrical ratios, because sometimes it's confusing. You want to give the ratio of the sine, you talk about the cosine. You sometimes mix them up. So let's find a way of solving that problem. You see, what way can we solve that particular problem? The only way we can solve that particular problem is to sort of develop what we call an acronym, okay, which we can always look at, you know, in case we want to forget the definition of the trigonometrical ratios of the three. And Good. So just like what I said, this is the angle, this becomes the opposite, this becomes the hypotenuse. So basically speaking, for the sine, you always say the sine of the angle they are talking about, which is theta. The sine of this angle, which is theta, it is opposite all over hypotenuse. That is why I have represented this whole thing into kind of letters to say sine is opposite all over hypotenuse. So we call it SO. This is SO, S-O-H. So by the time I finish all three of them, we can combine all together and form an acronym you can always remember in case you forget the formula. So it's like for the sine is SO, which is sine equals opposite all over hypotenuse. Sine equals opposite all over hypotenuse. And then we have the next one, which is the cosine. So for the cosine, abbreviated as cos, the cos of theta is always equal to adjacent all over hypotenuse, and it's the CAH. It's the CAH, C-A-H, you see, which is adjacent all over. Cos equals adjacent all over hypotenuse, like you see it there. So that is what we call the CAH. And we have the third one, which is the tangent. The tangent, this is the tan. We call it the tan of theta. And the tan of theta is always opposite all over adjacent. That is why you have TOA, which is TOA. TOA. You see? So we have the co, we have the CAH, and we have the TOA. Okay? If we join these three words, you can see that we'll end up getting this, which is sine is opposite all over hypotenuse, cosine is adjacent all over hypotenuse, and tan is opposite all over adjacent. If you combine all those letters, you will have a word we call SOHCAHTOA. So if you can be able to memorize this word, it can always help you. It can always help you in identifying or sort of work the ratio of all these three trigonometrical ratios. And as you can see it, sine, as you can see it there, sine is opposite all over hypotenuse, and cos is adjacent all over hypotenuse, and finally tan is opposite all over adjacent. Exactly. So I hope this one is very, very, very clear. So if you can memorize the trigonometrical ratios like the ones I talked about before coming here, that's okay. But if you think you cannot memorize that, just memorize this whole word we call SOHCAHTOA. So that anytime you are taking an examination, for you not to forget, write this particular word before solving so that you don't get mixed up, especially for the sine and the cosine. That's where the mix-up always comes. Students sometimes say for sine, it's always adjacent all over hypotenuse, which is not correct. Sine is always opposite all over hypotenuse, and cos is adjacent all over hypotenuse, and of course tan is opposite all over adjacent. So this is a better way for you to remember, okay, the trigonometrical ratios, so that whilst you are solving the problem, it's always very, very easy for you to remember them. All right? So let's see. So we now come to how we can find the missing angles. If an angle is divided into two parts, please let me just make this one clear. Another video will come that is basically going to talk about how you can find the sides. But as far as this video is concerned, I'm concentrating more on how you find the angles. All right? When you understand how to find the angles, no matter how they draw the question, as long as they are asking for the angle, if you know how to find it, then it becomes much more easier. You see? So the next video, then I am going to specifically treat about how you find the sides. But for this one specifically, it's going to be how to find the angles. And so look at this. Find the side of the missing angles in the triangle below. Look at this. So this is one example. Let's imagine a question like this is given, and what they ask you to find is going to be angle x, and you want to find this angle x. How do you find it? The first thing, just like what I've explained, is identification of the sides. You ask yourself a question. What is the relationship of this side to this angle? Of course, just like what we see, this is the opposite. And this other side that is given is the adjacent. So you can see that you've got opposite all over adjacent. And we now know that opposite all over adjacent is always the tan. So it means the tan of x is going to be equal to opposite, which is 3, all over adjacent, which is 6. So that the tan of x is now going to be 3 all over 6, I guess, which is half, and half is 0.5. 0.5. Once you get to this point, where you have tan x is equal to 0.5, you always take the inverse of this angle. And this is how you write it. If you want to take the inverse of sine, it's going to be sine inverse. And sine inverse